This video is about the objective identifying the null and alternative hypotheses, or hypothesis. This is number 2. Okay, this is the second video on a question related to this objective from your Newton Alta homework that I'm working on. So should be a little shorter than the first one, right? I'm going to do a little less explaining than I did in number 1. But let's take a look, right? Let me go over the page. I wrote out, how do you form hypotheses once you know a claim? So let's go over that again here. So again, some claim is going to be made about a parameter, about a population. So like some claim, the population mean is greater than 7, or the population mean is equal to 10, or the population proportion p is less than 0.2 or something. I don't know. But some claim will be made about a population parameter. And then from that claim, the hypotheses are formed. You have these two opposing hypotheses, the null hypothesis and alternative hypothesis. Now the null hypothesis, which is labeled by H0, always involves an equal sign, right? Part of an equal sign. So it could look like one of these three things. The parameter equals some value, the parameter is greater than or equal to some value, or the parameter is less than or equal to some value. Now in this book, in your Newton Alta work, they only use the equal part. Alright, so you're not going to see the greater than or equal to or less than or equal to showing up. Because I think the reason they're doing that is because when you perform the tests, later on we'll do this in other, future videos, of course, when you perform hypothesis tests, you're going to be assuming the equality. You'll assume that the value of the parameter equals a certain value, and then test that, and then see if that assumption is a good assumption or not. And then the opposite of the null hypothesis, the negation, the contradictory statement, is the alternative hypothesis, right? HA or H1. There's an N in there. Sorry, alternative. And if the null hypothesis always involves equality, this never does, right? The alternative hypothesis never has an equal sign. I mean, it does. This has an equal sign with a slash through it. I mean, there's never equality there. So the alternative hypothesis could look like one of the following. The parameter is not equal to a value, and if that's the case, then you're performing what's called a two-tailed test. The parameter is greater than a specific value. If that's the case, you're performing what's called a right-tailed test, or the parameter is less than a specific value, and in that case, you're performing what's called a left-tailed test. But we're not being asked about the types of tests here. We're just asked about forming the hypotheses. All right, so let's go to the question. So in 2018, a bank analyzed the number of times mortgage payments were paid after the grace period. So let the mean number of times a mortgage was paid after the grace period be mu, right? The population mean, the population average. If the bank wanted to know if mortgages were paid after the grace period on average, more than 4 times in 2018, what are the null and alternative hypotheses? Alright, so I'm going to pull out a piece of paper here. We're going to look at this. Now, mu was this average number of times a mortgage was paid after the grace period. Right. And they talked about testing, right, so this mu, and they talked about saying, hey, the bank wanted to know if mortgages were paid after the grace period on average more than 4 times. More than 4 times. So that's mu, this average number of times a mortgage was paid after the grace period, is greater than 4. And I guess we could consider this the claim if we wished as well. Right? That's what they want to figure out. Well, notice that this doesn't involve equality. meaning it's going to be represented by the alternate hypothesis. All right, so when we form our hypotheses, you have the null, you have the alternative. This mu is greater than 4 is going to be my alternative hypothesis. All right, and then again, once you have one of them down, the other one's just the opposite. All right, what's the opposite of being greater than? It's being less than or equal to. So this is a perfectly valid way of writing the null hypothesis, but what's going to be assumed is what they're writing. So that means we're going to assume when we perform the test that mu equals 4. All right, and this is what they're using instead of less than or equal to. Just know that less than or equal to, greater than or equal to are perfectly valid symbols to have in your null hypothesis. It's just that in this particular book, in this Newton Alta, they're using just what's being assumed. They're using just the equals. Okay. So back on the website, mu equals 4 for the null. Mu is greater than 4 for the alternative. That's exactly what I had written. Submit that. And fantastic. Right? And go through your answer explanations all the time, especially if you're wrong. Read through the answer explanations, see if you can figure out where you went wrong. And that's it. Alright, and this is my second video on these, so hopefully you've seen one with proportions, one with means. And hopefully you can take the statement they're giving you. If it's got equality involved, if it's like at least or at most, if it's got equality involved, then it's going to be represented by the null hypothesis. If it doesn't have equality involved, just more than or less than, not equal to, then the claim, the statement being revealed to you, will be represented by the alternative hypothesis. It's really that simple. So hopefully these videos help when you're going through this on your own. And thank you very much for watching.